If you'll recall from our previous video, we talked about using a PDF file called Corrosion Control, and we're going to break it up into 6 videos that will then list underneath it. So I'm going to go through and show you how to create the first video and then embed it into the lesson. So the first thing we want to do is open up this Corrosion Control PDF and then go to the first slide, and we said that we're going to go through slide 10. So I'm going to do a very quick voiceover of each of these to show you how it works. Notice also I'm going to resize the screen, I think. So now I've resized the screen so that you only see the slide itself. I had to actually hit pause to do that. You can't resize the screen as you're recording. You have to click on the pause button to stop, and then you can resize the screen. So now I've got the video window equal to the size of the slide. So let's begin. This is Corrosion Control. This is a presentation created by Wayne Hyatt from the NCWA. This is the first of 6 videos that will cover this PowerPoint or PDF presentation. You will see that within the lesson module that the PDF exists in the entire form. We suggest that you print the PDF and then use that as you go along as we talk about each slide. So what are we going to cover in corrosion? We're going to talk about the basic concepts of corrosion, the factors influencing corrosion, methods of corrosion, and safety and handling of phosphoric acid, some of the chemicals associated with corrosion control. What are some of the adverse effects of corrosion? Well, corrosion can actually cause financial problems for your utility. It can be a financial burden, it can cause problems with delivering water, and it can damage your water lines. It also can be a health threat in that toxic materials like lead and other metals can be released into the water as pipes corrode, and you can have to manage complaints of both discolored water and taste and odor problems. What is corrosion? Well, corrosion is really the breakdown of the interior of a pipe due to a chemical reaction, and this reaction is a result of water interacting with the metal that's on the inside of a pipe. It's called an electrochemical reaction. And its idea is that metals, if it's iron or other type of metal that make up metal pipes, they want to return to their natural state. And when we make pipe, the metal is not in its natural state. It wants to go back to its natural state, which is kind of an ore or a mineral, and water being in contact with the metal will speed that process up. So what happens is that water will attack the inside of a pipe, and again, the steel and the iron and the other metals that are inside this pipe, they want to return back to their natural state. And to do that, the water acts through an electrochemical reaction to break down the metals. Metallic corrosion is always a result of an electrochemical reaction. So what is an electrochemical reaction? Well, it's a type of chemical reaction where the flow of the electric current itself is an essential part of the reaction. In this case, we have the pipe, and then we have water in the pipe, and water will act to allow electrons to flow from one part of the pipe we call an anode to another part of the pipe we call the cathode. And what happens when water is in the pipe, it's called an electrolyte, it allows for the flow of electrons. It will allow iron, which is one of the main metals that make up metallic pipes, will go from its regular state, which is metallic iron, and it will lose electrons and become what we call ferrous iron, which becomes dissolved. When that happens, electrons are released. These electrons then will react with water and the acid in water, which we call protons, to form hydrogen gas. So here's an electro reaction that's occurring, and as a result of this reaction in the presence of water, ferrous iron is released, and this ferrous iron will then react with additional water to form rust. And that is what causes the scale on the inside of the pipe. Another way of looking at it would be if you have, again, looking at a cross-section of a pipe, you have water flowing, and here's a couple reactions that, just for your purposes now, just be aware of, where you have water as the electrolyte, you have a cathode, and then you have an anode. And what happens on the anode is that iron gets released as ferrous iron. It reacts with the hydroxide in water to form rust. So you get this what we call tubercle or rust coating on the inside of the pipe at different points. That's why you'll see it at one point and you won't see it somewhere else. It'll be like bumps on the inside of a pipe. Here are some examples of some tubercles or chunks of rust that react. And what happens is that when you have two different types of pipe, instead of one continuous pipe, the actual process can be speeded up. So dissimilar pipes can really accelerate the process. In the first instance, we just had iron in the pipe, essentially corroding itself in the presence of water. But when you have two metal pipes, a copper pipe and an iron pipe, for instance, then you can create an electrochemical reaction between the two, what we call dissimilar metals, using the water as that electrolyte. This concludes part 1 of the 6-part series on corrosion. Complete the knowledge check for this section before you proceed on to part 2.